Hey class, so I'm going to walk you through your very last JASP of this research course. So this is lab 4.2, and this one's in ANOVA, right? This is the factorial design, the hardest one, the one you've all been looking forward to all semester. But then that's it, right? You did your correlation, you did your t-tests. We're going to do this ANOVA, and then you'll know how to do all the things in JASP and to write them up in APA format and to do everything you need to do to be successful as a future researcher in a master's program or for your senior capstone class. So I would keep these notes that you have in these videos handy in case you need a refresher in your future. So let me share my screen. We'll go to Canvas first. So I'm going to click on lab 4.2. Okay. Okay. So here's lab 4.2. The stuff at the top is the same, right? We were looking at the role of storage and retrieval queues to see if having an encoding queue present or absent or a retrieval queue present or absent affected the amount of correctly recalled words. So we have this research by Tolving and Pearlstone from 67. They did 24 unrelated words in 19 conditions. We didn't quite get that crazy. You had 4 conditions: CC, CNC, NCC, and NCNC. So you had your 4 conditions, 1 participant for each condition for each student. I've brought all the data together in one big CSV file that I've sent out to you. So here's the data analysis and write-up. So you want to download the CSV file, you're going to analyze the data, then you're going to write your manuscript. You need to determine the mean number of correctly recalled words, obviously standard deviation 2 for each of the 4 conditions, and then perform your 2x2 factorial analysis of variance, ANOVA, on the data. Your lab report has to be in APA format. Use your templates from the last few labs. Make sure you go in and look at all of my feedback because I've commented on every single person's paper anywhere there was a APA mistake. So there's no reason this one shouldn't be perfect. You have your introduction where you restate the purpose of the study, which is like the information above, no more than 2 paragraphs, maybe just 1 paragraph, but write it in your own words. And then describe the method of the study. So remember in your method section, your first section is introduction. That's your first level 1 heading, but it's not the word introduction. It's the title of the paper. Your second level 1 heading is method, and you're going to have 3 level 2 headings underneath the method level 1 heading. Participants, materials, and procedure. Participants, how many, mean, standard deviation, age range, genders. I'm not going to show you how to do that in the video. If you don't remember, go back to the lab 2 help video I sent you where I showed you how to do that. Materials, describe the list of words and the cues. Procedure, describe the procedure of data collection and what data you recorded. So then for the results section, your next level 1 heading, describe the results of the ANOVA. Tell me what you did. And it needs to look like this, right? A lot of you are struggling with the way that you're writing your statistics out. You're trying to make it really wordy, or you're just throwing up some numbers. This is what it looks like in APA format. This is how you report in ANOVA in APA format. So obviously this is a different example, but same idea. So change the words to what they need to be, but a 2x2 factorial analysis of variance having 2 levels of recall, maybe, right? And then put what they are, and 2 levels of whatever the main effect yielded an F ratio of, and needs to look just like this, indicating that the mean score was or was not significantly greater or smaller for whichever situation you're talking about. And then you report the mean and the standard deviation for that one, than for the other situation. And then you report the mean and the standard deviation for that one. And then the main effect of the other one was F, here's your degrees of freedom, equals, here's your F stat, p-value indicating the mean change score was significantly higher, was not significantly higher, lower, whatever you're saying, right? Whatever your data is telling you. But it needs to look just like this. So there's your 2 main effects and how you report them. And then here's the interaction effect. The interaction effect was or was not significant. F stat, degrees of freedom, here's your F stat, P equals less than if it was not significant, or P equals whatever P equaled if it was significant. Just like that. And you can see it's a lot bigger, right? Because there's a lot. In the 2x2 analysis, we have the main effect for the first thing, the main effect for the second thing, and then the interaction effect. So you have to report all the data for all three of those, just like this. Any deviation from this, I'm going to take off a lot of points because I'm tired of y'all not reporting it in pretty APA format when you can. You have your APA book and you have this exact example here. So you can do it. Pay attention. And then the discussion section. So you need at least a paragraph for each one of these bullet points. Answer each question in a separate paragraph, but it needs to flow. What conclusions can you draw about the usefulness of the cues given during encoding and retrieval? Were the cues useful if provided only at encoding but not at retrieval? How could they be a source of interference? Were any cues incorrectly recalled in the CNC condition? Were cues helpful if introduced only at retrieval, the NCC condition? What strategies did any of your participants report using? What did they report about the use of cues? And then you need to have these references at minimum, and hopefully you have a couple of more references, but you need at least these ones. So I'm going to share to JASP. And again, this is an example file from a previous semester, so this is not your data. Okay, so this is an old example. So let's see, we've got age, gender, encoding cue, retrieval cue, correct recall, and false recall. Let me make sure you can see this. I'm terrified that screen share won't actually share. Let's see what you can see. Oh, you probably couldn't see it. Okay. Yes. Okay, now you can see it. All right. So age, gender, encoding cue, retrieval cue, correct recall, false recall. So what are we going to do? We're going to do the factorial design ANOVA right here, right? So you've got some options: ANOVA, repeated measure, ANCOVA, MANOVA. We just want a regular old ANOVA, 2x2 factorial design. So the dependent variable, right, we're just trying to see if, well, let me make sure all of my variable types came in right. So make sure your variable types are right. Age, gender, encoding, retrieval, correct recall, false recall. Nominal, interval, ratio. I'm going to change age to interval ratio. Okay, so where were we? ANOVA. Okay, so we're about to conduct our ANOVA. And what do you think needs to be in the dependent variable? Take a second, think about it. What are we measuring? We're measuring correct recall. That's right. We want to see if correct recall was affected or was dependent upon what we were manipulating, right? Our fixed factors. What were those? Those were whether there was an encoding cue or a retrieval cue. So now it's doing the ANOVA. Okay, so you know what this means, right? Because you remember from statistics what this is. But in case you don't, so we have our very first, here's the output, right? And so a 2x2 factorial design has two main effects and one interaction effect. So it's giving you the main line, this line here for encoding cues, main effect, retrieval cues, main effect, and its numbers, and then encoding cue with retrieval cue, this interaction effect. So that's why we have three lines for the 2x2 output. So the main effect is what you get if you average out all the other variables, and we're not dealing with those. So, right, so if we're just looking at an encoding cue and its main effect, these numbers are averaging out all the other stuff. Same for retrieval cue. And then the encoding by retrieval cue is if those interact together at all. So let's just look at our numbers here for my example. I have a p-value of 0.16. That's not significant. 0.02. That's significant. What is this? Retrieval cue. So there's some significance in my retrieval cue. And then 0.08, no significance for retrieval by encoding. So no interaction effect, but it does look like I might have significance here in my retrieval queue. So we'll talk about that in a second. So we know there is an effect, at least on mine, for retrieval queue, but we don't know what it is. So let's look at some data, a different way to just kind of see what we can see. So I'm going to go to descriptive plots on my pull down over here. And you can do whatever you want, but I'm going to put encoding queue on the horizontal axis and then retrieval queue on separate lines. You do not have to include this in your paper, but if you want to, you could screenshot this, make sure you give it the appropriate APA headings and notes and stuff. But let's see what I got. So it looks like if I said up here that my retrieval queue had significance, let me find retrieval queue. When retrieval queue is present, it looks like as retrieval queues were present, my correct recall went up, apparently significantly. And then when retrieval queue was absent, it didn't really change anything here. So that's pretty cool. So I know that my retrieval queue was significant, and the significance is that the encoding queue being present increased correct recall. That's awesome. That's what we expected to happen. Hopefully, for some of us did. And then to see, you see here, there's no interaction effect. You can see that because of the way these two lines are going. So one line is going this way and the other line's going this way. And so maybe they would interact a little back here, but they're going completely separate ways. So they're not interacting at all. And then if we're not seeing the significance right up here in coding queue, maybe it would have just taken more participants. The problem with this is everybody has 4 participants. So we've typically had our 2 groups have like 50 plus people in them, but everybody only had 1 person in each condition. So probably each condition only has 20 something people, depending on how many people turned in their data and such. So typically we like to say you have to have an N of 30 to really get accurate results, and then more than that, right? So if we're trying to wash out some variables with a higher N. So it's a really small N, so that might be something that we see. And then remember for your means, you can find the descriptive statistics. I find it over here. I think I'll just click up here, descriptive statistics. So for encoding queue, retrieval queue, okay, so you can see over here, I have my ages and correct recall. I'm looking for my means. Here's my means. That's not right. Hold on. Let me take out something. I want the mean for the encoding and retrieval. Please hold. And my screen share is in the way, so I can't see down here. Okay. Correct recall. Not what I want. Just, hold on a second while I play with this stuff. Standard deviation. Yes, yes. My correct recall mean? I guess you can just do it this way. So here's correct recall, and I get my mean and my standard deviation, and then I'll just take it back out, and then I'll put in coding queue, I'll put in encoding Q, correct recall, and get my mean and standard deviation. And then I'll take out encoding Q, and I'll put in retrieval Q and grab my mean and standard deviation. There's probably an easier way to do that, but I did it that way. So now I have my means and standard deviations that I can report. And then again, for your gender and ages and such, refer to lab 2 video or just play with it, figure it out, because I know you can do it. So that's all I have. If you have questions, email me, but that's it. That's your last lab of the semester. Great work.